So now we'll go to a walkthrough of NLP Deep Learning 10 years collab. So as we always start with a setup, this cell imports the NumPy, Matplotlib library, PyTorch and visualization libraries. These are used to demonstrate NLP concepts and through small from scratch implementation. Next, I'll go for tokenization. So, tokenization, this section explains tokenization, which means breaking text into smaller pieces called tokens. Next, in cell 7, we'll see visualize different tokenization strategies here. And next, we'll build a simple um, word level tokenizer. The key point is that the text must be converted into numbers before a model can process it. So we saw how it was encoded and then it is decoded into I love neural network. Next, let's go for word embeddings. And here the notebook explains word embeddings instead of representing word as a random IDs. So embedding represent word as a dense vectors here. Similar words have similar vectors. The similarity heat map and 2D projections. If we scroll down, here the heat maps and all the 2D projections we can see here shows how words can cluster based on meaning. Yeah. Next, let's go for word analogy. This demonstrates the famous analogy idea like king minus man plus woman is equal to queen. The purpose is to show that embedding can capture semantic relationship, not just word identities. Next, let's go for simple RNN. These are all 2D visualizations that I was like saying before. And next is RNN, which is recurrent neural networks. And this cell that I'm showing next implements a simple RNN from scratch. And RNN reads a sequence one token at a time and carries a hidden state forward. This hidden state acts like memory, helping the model understand word order. Next, let's go for LSTM. And this section explains why basic RNNs struggle with long sequences because of vanishing gradients. The LSTM improves this using gates, which is forget gates, input gate, and output gate. These gates decide what information to keep, update, or output. Next, let's go for sequence to sequence. Yeah, so this cell visualizes encoder decoder architecture. The decoder reads the input sentence and compresses it into a context vector, while the decoder produces the output sentence. Mm, this was important for tasks like machine translations. We can see how the encoder is here trying to translate the French into English words. And let's go for attention next. This section introduces attention. Instead of forcing the model to store the whole sentence in one vector, attention allows the decoder to focus on relevant words from the input sequence. This solves a major limitation of basic sequence to sequence models. Next, we'll go for self attention. And yeah, so here we move into transformer concepts. Self attention allows every word in a sentence to look at every other word. This helps the model understand a context much better, especially when relationships are long range. Next, let's go for multi head attention. So this helps multi head attention. Instead of using one attention view, the model uses multiple heads. Each head can focus on different relationship like grammar, meaning, nearby words, or long distance dependencies. Next, we'll go for position encoding. Transformers process words in parallel, so they do not naturally know word order. Positional encoding adds position information to each token so the model can understand sequence order. So, the causal mask is the next topic that we are going to talk. And causal mask, this cell, mm, This cell visualizes the causal mask, uses a GPT. Yeah, this cell uses a GPT style models. It prevents the model from looking at future tokens while predicting the next token. This is important for language generation. At last is BERT, GPT, LLMs, and alignments. The final section here summarizes the evolution of NLP models. The BERT is encoder only and strong for understanding task. GPT is decoder only and strong for generations. So we can see later model becomes larger and were aligned to be more helpful and conversation. This is the whole 10 years of NLP breakthrough that we discussed from beginning to end of this collab. That's it of the walkthrough. Thank you.